Class, this little brief video is pertaining to Chapter 1. I'm looking at your book right now, actually. And a couple of things I wanted to highlight, actually. As you see, the book starts out telling you that the two main approaches in this book are to focus first on descriptive statistics and then second on inferential statistics. Now, the first 4 or 5 chapters of this book are devoted to descriptive statistics, which basically is describing a large data set, a large list of numbers, making the large list of numbers easily understood by an audience without the audience having to wade through the large amount of numbers that may be listed on a screen or in a magazine article or whatever. So we are taking a large amount of data and describing it in a manageable way by using some various statistics that would summarize the data. So as an example, if I wanted to know the income of all the people who lived in North Carolina, rather than list 16 million incomes or thereabouts, I might take an average, right, of that income. By the way, you're going to learn in one of the chapters coming up that when we take an average, we can take a mean average or a median average or a modal average. We'll just leave it at that. The average that you're most familiar with is when we add up all the numbers and then divide by the amount of numbers on the list, and we get the average, like when you want to figure out what your scores on a test will produce for your final grade. So descriptive statistics is not that hard for us to get our arms around and to understand. But inferential statistics is another matter, and that's what the second half of this book is devoted to. Inferential meaning to make an inference about something, to make a prediction about something. This is very powerful, and it's a very powerful point in statistics, that we could actually take a sample from a large population of whatever, take a small sample, and make a guess or an inference about whether that sample is accurate and the extent to which it's accurate and the likelihood that we might be wrong. What's the probability of error? So the second half of the book is very, very powerful in terms of inferential statistics and trying to understand the probability that something will or will not occur. This may sound a little bit confusing to you right now, and I understand that, but it's important for us to keep talking about these things, because in statistics, if we don't stay abreast of the material and we don't work through it, then we collapse later on, because in statistics, one point is built on the previous point, which is built on the previous point, etc. So I want you to keep these things in mind. The other point that's mentioned in the first chapter that I think is really important is when we're describing statistics, your author mentions that we can talk about describing univariate statistics. That would mean one variable, or bivariate would mean two variables. And of course, we have multiple variables, which we will deal with later on. Another term that's used in your first chapter, which relates to samples and populations. Well, let's just use an example here at the university. Let's say I wanted to know what the average age is of all of the students at the university. All of the students at the university would constitute the population of all of the students at the university. And from that population, I want to try to pick a representative sample. So the population refers to the group or the population from which you're drawing your sample. Then you have your smaller sample, and then you're going to pick only one sample, and you're going to take the average age, and you want to know, well, did I really pick an accurate sample? Is this sample really representative of the population? These are things we'll be learning about in the course. So I think it's really important, though, that we get our terms in order. Population versus sample. Bivariate, univariate statistics, as I mentioned a moment ago. Again, in the first chapter, your author talks about discrete variables and continuous variables. Now, this is going to get into the next section of the chapter 1, where he talks about levels of measurement of a variable. First, make sure you understand what a variable is, and there are numerous examples in your book, by the way, numerous examples in life. A variable. What is a variable? Well, if I looked at the variable gender, it can take on two qualities or two attributes, male or female, right? So it can vary. If I used a variable called exam scores, that would vary by the different exam scores that were given on a particular exam. Another variable could be level of education, because that would vary as to whether or not you completed kindergarten, high school, junior high school, college, or whatever. So a variable is any item that varies, right? It's not a constant. And a discrete variable, I like to say, has walls around it. So the easiest way for me to describe that to you would be, for example, if we have a variable called religion, and religion can vary in any number of ways, but I'm just going to choose an example. Let's say we select, and we can choose anything we want. Let's say we take the variable religion and we want to break it down into the following attributes: Protestant, Catholic, Jewish, and other, right? Well, each one of those categories, Protestant, Catholic, and Jewish, they are separate and discrete. They don't run into each other. You're either Catholic or you're not, or Protestant or you're not, or other or you're not, etc. So that's an important point. They're categories and they don't run into each other. They are separate and distinct. Now, the other item under this topic that your author talks about is continuous. A variable can be continuous, which means there are no walls or barrier in between each category. So, for example, a typical example of a continuous variable could be one's age. So age is the variable, and then your actual age becomes the attribute of that variable. But if you think of age, right, it's a numerical process, and the distance between 1 and 2 and 3 and 4 and 10 and 12 and 13 can be broken down an infinite number of times, so that you can almost have no separation between the age of 12 and the age of 13, depending on how finite you want to get in breaking down the distance between each one of those attributes of the variable, meaning between the ages. Ages can be broken down an infinite number of times. So can things like temperature. So can things like your weight, and so on. So some variables are continuous in that they run into each other, and some variables are discrete, right? And if you consider the levels of measurement of variables, this is where this becomes really important, right? A level of measurement of a variable that is discrete, right? Protestant, Catholic, Jewish, for example. You can't really add them up and take an average. It's very unsophisticated mathematically, right? And that's a lower level of measurement. We call that level of measurement the nominal level of measurement. We also know it as the categorical level of measurement. One step up from the nominal or categorical level of measurement is the ordinal level of measurement. Now, an ordinal level of measurement can also be categories that are distinct and discrete, but they can also be rank ordered, higher or lower. We just don't know exactly how much higher or lower. So, for example, you've all seen these surveys over the years where you're asked a question and then you have to put down whether you don't agree, or strongly don't agree, or mildly agree, and strongly agree, etc., etc. Well, we know that each of those categories is higher than one of the other categories, but we really don't know by how much. By the way, when we talk about age or exam scores, that's a more sophisticated level of measurement. We know exactly how much higher a temperature of 36 degrees is compared to 32 degrees. Or we know exactly how much older being 24 versus 12 is, because that's more precise. But ordinal level of measurement is not that precise. It's not a continuous variable, and the categories are discrete, similar to nominal. The only difference between nominal, which is also known as categorical, and ordinal is that they both have categories, but the only difference is that with an ordinal level, those categories can be rank ordered from high to low. With the next level of measurement, which is the highest, and in our class we refer to it as the interval ratio level of measurement, right? That's a very sophisticated level, and that's similar to what I just told you about, something that's numerical, something that we can do a lot of math on, something that we can take the mean average of. By the way, you cannot take the mean average of a variable measured at the nominal or ordinal level, but you can at the interval ratio level. And so that's a kind of a convenient shorthand way for you to identify what constitutes an interval ratio level of measurement. So pay attention to the levels of measurement, because it's not as easy as it seems at first appearance. Those are some of the highlights that I wanted to give you for the first chapter. I hope that you're working through this and that you're enjoying the class. If you have a question or two that you ever send to me, I will try to address it for you. And I wish you the best of luck. Take care.